Good morning and good afternoon. This is a review for Benchmark 3 and what you'll be taking on Friday. If you note at the top that this is not the test, this is a review and you'll be taking the test Friday, you should be there. Okay. The three standards that we're testing is that you can do unit conversions. This is actually a very easy benchmark compared to the quiz and problems that we had as we worked through the unit. With a word problem here, which isn't too bad, you can solve proportions, which hopefully you can do. You can use proportions to solve some word problems and similar figures. Okay, and that would be it. We'll have a separate test on percents, which we've been dealing with definitely before Christmas break. Okay, my suggestion to you today is that if you can do these problems and you think you have the right answer, okay, my suggestion to you is that you try to work on them and see what my solution is. When you do take this benchmark, note that you will have a conversions worksheet next to you. Okay, so you don't have to memorize everything. I don't expect that, and I'll be referring to this throughout the video so you can see where we're getting things from. Okay, you need to know where to find these things though, remember. So moving back over, okay, in this case right now we're doing conversions. Like I said, if you can get through this video or you can get through this worksheet without the video, feel free to work on it, and you can fast forward to where it gives the solution and check your solution against mine, and if it's not right, go back and check it over. Tomorrow we'll be working in some groups on a second review, and Friday we'll take the test. Okay? So we need to convert meters to kilometers, 1,500 meters to kilometers. So I'm going to write 1,500. Remember meters, I write that over 1, and now I need to convert it. So that means I need to go find a conversion, right? A conversion rate to see if I have meters to kilometers. Now both of these are in the metric unit. So as I move over, let's see the metric over here, and we are measuring length, which I can see. So do we have meters to kilometers? Yeah, 1,000 meters is 1 kilometer. And remember, when you're trying to convert, we have to get rid of, we put it in the opposite place. So meters goes down here, kilometers is what I want, and 1,000 meters is 1 kilometer. And we do what at the end? So now it canceled. We have kilometers left, that's what I want. So we'll end up with so many kilometers. 1,500 we multiply across times 1 is 1,500. 1 times 1,000 is 1,000. And I think many of you could have done this in your head, that it turns out to be divide in the end. 1.5 kilometers. That is our solution. So 1,500 meters is 1.5 kilometers. Our next equation deals with a different type of measurement. Quarts in gallons, which is not part of the metric, that's part of the customary. And in this case, it's measuring what looks like ounces, fluid ounces, not fluid ounces, but volume in terms of liquid capacity. Okay, and we needed to go from quarts to gallons. So let's see if there's any conversion from quarts to gallons. Yep, looks like there's an easy one that I find down here. And if you didn't know, 4 quarts is 1 gallon, so this makes it pretty simple. Now the questions on your benchmark won't be exactly these things, but very similar. Sometimes I just change the numbers. So remember, write 12 quarts over 1. We're trying to change this to gallons, so if I need to get rid of quarts, right, quarts goes on the bottom, and then gallons will go on top. And what was it? It was 4 quarts equals 1 gallon. Multiply, quarts cancels, so that's 12 up top, gallons, no units on the bottom, that's 4, and we divide in the end, so we get 12 divided by 4 is 3, so that would be 3 gallons. Some of you could do that without even doing a conversion, I'm sure, as well. This next one is what many of us get a little confused on when we have a certain distance along with another one added on. I'm asking you to convert 2 miles and 220 feet, it doesn't say it here, to feet. Hopefully it says it on your worksheet, it will. Okay, so we want to convert 2 miles and 223 feet to feet. So if you think about it this way, let's let this represent 2 miles. Okay, and then all I've done is saying and 223 feet. So if I'm converting all these to feet, I just really need to find how many feet 2 miles is, right? How many feet is that? and then just add on 223 feet. Hopefully that makes sense to you. Just like if I said, right, you're 5 feet 10 inches tall. If I wanted to know how many inches you were, well, I know you're 10 inches plus however many inches are in 5 feet. So maybe this is 5 feet, and then you have your 10 inches up here. Double dash means inches. Okay, that's 5 feet. Well, each foot is 12 inches, so 12 times 5, that's 60. And 60 inches plus 10 inches, you'd be a total of 70 inches. Hopefully that makes sense. That's kind of what we're doing, but in terms of feet and miles. I'm just going to get rid of this here. Okay, let's go back. So here's what we need to do. We need to convert 2 miles into feet and add on 223. Okay, so 2 miles, we need to get to feet. So if we're going to convert that, put 2 miles over 1. We need to convert it. So miles actually does convert to feet. So miles goes on bottom since we're getting rid of it. Okay, and if you didn't remember what it was, go back up. We're looking at length. Turns out that 5280 feet is 1 mile. Okay, now we can go back. We said 5280 is 1 mile. Okay, so remember, I'm going to multiply across. Miles cancels. 2 times 5280. That's going to be 1,000. Oh, I need to write it in a different spot. I'll write in red. 1,560, right? Feet. Oh, that's not 10,000, sorry. 560 is what I meant. Okay. And I'm going to add that to 223. So I'm going to do that by hand. We'll do it over in here. It's 10,000, say, 560 plus 233. We'll do this by hand. That's 3, that's 9, that's 7, that's 0, and that's 1. So it's 10,793 feet. Make sure you're putting units on these. Okay, if you forget your units, it's not right. And our benchmarks are either right, or all wrong. So if you would have had 10,793 but you forgot your feet and to circle it, doesn't work out. Okay, not going to get credit, just like 3 gallons and 1.5 kilometers. Let's try number 4. Not too bad. I'm asking you to convert 15 miles in 1 hour to feet per second. Okay, if it doesn't say 15 on your paper, I apologize, but you can write it there. 15 miles per hour to feet per second. Okay, so actually that means we're doing 2 conversions. We need miles to feet and hours to seconds, right? That's when we went both ways on this, right? I'm going to move this over here. You should have some more space on your paper. So 15 miles in 1 hour. We want it to feet per second. So I'm going to do the top. Let's convert miles to feet. Since we're going to get rid of miles, mile goes on bottom. Feet goes on top. It is 5280. Okay, and miles cancels. I get feet. So I'm set to go there. And now when we go to convert our hours, we're going to convert that to seconds. So let's think. If we're getting rid of hours, hours breaks into minutes. 1 hour is 60 minutes. Hours cancels, right? Now we need to get rid of minutes and go to seconds, right? Minutes goes up. 1 minute is 60 seconds. And then at the very end, minutes cancels and we get seconds. So we're good there. Multiply everything across. We'll get a total. That's going to be 79,200 over 60 times 60 is 3,600. And remember, at the very end I divide. So when I divide that, this will give me a unit rate, right? It actually turns out to be a nice little number, 22, and then I have 22 feet per 1 second. Okay, because that was the units I was looking for. 22 feet per second is the same as 15 miles per hour. Not too bad. That would mean that if you can run at 15 miles per hour, you're running at 22 feet in a second. Those are pretty long strides right there. All right? That's the answer to number 4. Gotta delete some of that so we can read 5. Let's continue. It says, Derek has challenged himself to sleep as much as possible at night for the last 2 days. He wants to know how many seconds he was asleep for. If he slept for 7 hours the first night and 12 hours the second night, how many seconds did he sleep in total for the 2 nights? So there's 2 ways to do this. I can either convert 7 hours to seconds and 12 hours to seconds and add those together, or I could just add the hours up, right, and get 19 hours and convert that to seconds. Hopefully we can do that simple conversion there, right? 19 hours, put it over 1. And let's make that quick conversion. You could probably do that without even looking at anything, right? Hours I need to get rid of. 1 hour is 60 minutes. And then we know we got hours done. We're left with minutes, but we want seconds, so get rid of minutes. Seconds on top. 1 minute is 60 seconds. So really I'm multiplying 19 by 60 and by 60. And that turns out to be 68,400. Hopefully you got that answer. And that unit is seconds. Okay, so you would have slept for 68,400 seconds those 2 nights. All right. The next thing to do is proportions, which I'm sure many of you are very good at. Remember, the way to solve proportions is to cross multiply. So if you'd like to pause here and try to solve the first 2, you should try to find your answer. Going to multiply there. That's 2 times 18 is 36. 5 times y is 5y. And then I'm dividing by 5. Okay. 5 goes into 36 7 times with 1 remainder. And that's a 1 out of 5, so it's going to be 7.2 equals y there. Y equals 7.2. Hopefully you got that. I will try the next one for you. Once again, we're cross multiplying. There's only 1 term in each here. 3 times 12 is 36. Negative 2 times x is minus 2x. And remember, since it's negative 2 times x, we divide. And when I divide by negative 2, 36 by negative 2 is negative 18. And that will be x there. Okay. Number 3, I'd like to take a peek at that real quick. Remember that in these types of proportions, when you have more than 1 term, okay, we have more than 1 term on the bottom, it's not just a number or a variable. I need to remember to do one thing, and that's put parentheses around it. Okay. The method still is the same, that we need to cross multiply to solve. I'm going to get some more space over to the side here to do this one. Okay, when I cross multiply negative 2 and the quantity x minus 3, that's negative 2 times x minus 3. Okay, I'm going to write the other proportion to the right here. And then 7 times 4. 4 times 7 is 28. Okay. Now if you're remembering what to do on this one, remember that this is still just an equation. Remember what parentheses and a number outside it means. It means distribute. Right? Let's make sure that we distribute correctly. You need to make sure that you're multiplying the numbers. I'll go from left to right. 28 negative 2 times x is minus 2x. And negative 2 times negative 3 is positive 6. Don't forget to distribute to the second term. Okay? Now it turns into like a 2-step equation. Remember, we want to get all your numbers to one side, all your variables on the other side. So split it up. I see number, variable, number, right? Probably makes sense to move these together to one side and keep our x's over here. So I would say we need to get rid of 6 and move it over here. Remember, the only way to move things is to add or subtract. So that's a minus 6. That's a minus 6. So we get 22 equals negative 2x. And then at the very end, negative 2 is multiplying x, right? So opposite is to divide. And you divide by whatever it is to get rid of. 22 divided by negative 2 is negative 11. And that's what x is. We could check that if we really wanted to make sure it's true. Should be your answer there. As far as word problems go, you can also use as proportions to solve here. That's why it says I can use proportions to solve. Alright. And what I'd like to do here is look at some things. So it says a furniture factory makes 7 recliners for every 3 couches. That's a rate, right? So 7 recliners for every 3 couches. Alright. If the factory makes a total of 150 recliners and couches in a day, how many recliners were made? So 154 recliners and couches. Okay, this is actually kind of a tough question. So it made both of those. That was the total on both of them, right? So this one you kind of have to set up sort of a different way. You'd have to set this up with make sure you have the same type of things going on top and on bottom. Since I do want to know how many recliners were made, I'm going to leave that up here. This will be recliners. I'll write that as R. Okay, over the total for the day. The total for the day was 154, right? That's the total. Well, if we had recliners to a total on a simple level, we know it's 7 recliners, right? With a total of, for that, with this, if I had 7, then I'd have a total of 10. So that's going to be my total on this one. So if it's 7 recliners for the 10 total, I need to know how many total recliners out of the total for recliners and couches. That's the same variables right there, right? Recliners to total is recliners to total. That's one pretty easy way to set it up. I can't think of another way right now, but that's how I'm seeing it. And then in order to solve, I cross multiply. With these numbers I made up, we may get a decimal, so just be aware. Okay, I'm going to cross multiply here. 7 times 154 is 1099. And 10 times r is 10r. So then if we have to go and solve for r, we're going to divide by 10, right? And that would turn out to be 109.9 equals r, or roughly we could say 110 recliners, right? Looks like some numbers I chose didn't work out so nice. I just changed it from the one that was in the test, but it should be an easy number to work with in the test. Okay. All right, number 5. Out of the football team, 2 out of every 9 players are seniors. Okay. If the team has 81 players, how many of the players are not seniors? Okay. A couple ways to do this. You could find how many seniors there are, and then subtract that and find how many are not seniors. Or you can find how many are not seniors out of 9, right? So 2 ways to set this up. I could say 2 are seniors out of the 9, or blank are seniors, same one, right, out of 81. So let's check that out. Cross multiply. 9x equals 162. Let's divide by 9. X equals 18. So 18 represents the number of seniors on the entire squad. Well, if the squad is made up of 81 players, how many are not seniors? Well, that's 81 minus 18, right? 81 minus 18 is going to be 63. So 63 are not seniors. That means they could be freshmen, maybe, sophomore, and juniors made up there. All right, we're almost done. I'm going to continue on. Okay, we also looked at proportions with similar figures, right? Finding similar figures. In this case, they're naming sides and missing sides by letters. It's line segments. Technically, FE is a line segment, and hopefully you can see where FE is. That represents this right here. So I could call that X. And then we had a bunch of different ways to solve this, remember? I could use a proportion to solve since they're similar figures. Their sides are proportional. So I could say 10 is to 5 as 12 is to x, right? And cross multiply and solve. Some of you can already see that since 5 is half of 10, then x will probably be half of 12. You can see it that way if you want. So 10x there would have equaled 5 times 12, which is 60. And it equals 6, right? So that is true on this one. For the second problem, looks a little different, and you got to use some of your old knowledge here. It says solve for the radius of the large cylinder. Cylinders are all similar. We didn't really touch on these, but that's okay. The radius is this right here, that missing piece, so that we could call x. Okay. So if we're looking at similar dimensions here, first of all, we could say 15 is to 20, right? 15 is to 20, small is to large as, I'm looking for something with the radius, so we need something here. 6 is to x, right? Let's go ahead and cross multiply there, see what we come up with. 15x equals 6 times 20, that's 120. Divide by 15, and 120 divided by 15 is 8. So it would be 8 units in this case. Right, that would be the radius. Vice versa, we have things that dealt with shadows. Doesn't really give us a good drawing, but let's pretend that that's our tree. Okay. And this is supposed to be the other thing on a sunny day. Notice the shadow of a tree was 8 meters. So that's the shadow going on right here. This is that tree shadow. Okay. Maybe that's what it looks like. Well, that thing's 8 meters long. And the shadow of a 1 meter mailbox next to the tree is 3.7 meters long. Excuse me, 3.75 meters. And actually they're looking, find the height of the tree. It's looking to find this height. So we got some similar triangles. We can call this x. Okay. I'd set the proportion. I like going big to small is big to small. So height of the tree is to the height of the mailbox. So x is to 1 as 8 is to 3.75, right? Let's go ahead and cross multiply. That's 8 times 1 is 8. 3.75x. And then to solve, we need to divide by 3.75. And that will be 2.13. And that would be in meters. So it looks like the shadow is much bigger than the tree, vice versa with the mailbox. Its shadow is much bigger than it itself. Okay. This last one doesn't really have any words on it, but we're actually looking to find. You're looking to find x, y, and maybe it says that in your worksheet. I can't see that in front of me. It didn't print when I downloaded it here into the program. I believe you're trying to find this representation here. Okay, so actually if you look at what's going on, there are two similar triangles. I'm going to pull out and I'll show you what they are. There's this triangle here. Okay, so that represents kind of the small triangle. Let's write its dimensions down. That's 24 on the bottom. Okay, x would be its height there in this case. And then there's a big triangle. I'll highlight that in red. It's a similar triangle because they have the same angle here, the same 90-degree angle, and then a third angle that would end up being in common. Okay, triangles have three of the same congruent angles. They're similar. You'll learn that in geometry. So actually, its length at the bottom of the big triangle, can you see what that is? It's 32. Okay, its height I can clearly see up here is 20. Okay, and that's all I really need. So I have that one missing dimension. I'm looking for x, y, that height there, which we'll call x. Maybe we could have called it a or h, and set up a proportion to solve, right? Lots of ways to do it. I like 20 is to x, as 32 is to 24. Let's see what happens there. We get 32x equals 20 times 24. That's 480, I believe. I'll double check that. Yes, it is 480. And let's divide by 32. And that is 15. So that height of that triangle is 15 units, whatever it might be. I recommend that you go ahead home and study these things. If they're easy, that's great. You'll do very well on your test. There may be some different figures like trapezoids or something else that you have to apply this to, but should be quite easy. I would hope that everybody would score very well in this benchmark. If you're still bad at conversions, you need to come into City or after school today and tomorrow and get some help. It's just really simple, basic ones that we're doing. We're not asking for many challenging ones, but good luck on your benchmark Friday, and tomorrow we'll have a little more of a review on this and maybe some added percents. That's all.